Nuclear power stands at the heart of global energy competition.
미국이 현재 스탯 가게 되면 중국한테 다 뺏깁니다. 세계에서 제일 많이 건설을 하고 있고.
Securing energy is the key to winning the AI arms race. The U.S. government declared a revival of the nuclear industry, working together with national big tech companies to develop cutting-edge nuclear reactors. Big tech continues its massive investment in SMRs.
5 gigawatts of new nuclear with Amazon. That is minimum 64 reactors.
The advanced SMR race creates new opportunities for Korea's leading nuclear construction companies.
어떻게 하면은 이 시장에서 주도를 할 수 있을까?
DL's partnership is what enables us to have those steps.
Where do we stand in the SMR race in order to lead the AI era? Since the 1950s, the United States has led the renaissance of the nuclear industry. But by the 1980s, the supporting infrastructure had rapidly declined. China, India, and Russia took the U.S.'s place. Their build plans over the next decade led by a wide margin.
We invented this. We commercialized it at the very beginning. We built the first commercial reactors. We harnessed that technology. We were really good at this. We were really, really good at this. So that's something that we lost, and I really appreciate that we have an administration now that is willing to put in the resources to revitalize that capability. Because it's not just about nuclear. Nuclear is really an enabling technology for us to be able to do other things.
The AI era began with ChatGPT, but each question runs a massive neural network, which consumes significant power. So the demand for energy is increasing rapidly. By 2030, the combined electricity use of data centers worldwide will match the electricity use of the entirety of Japan. Increasingly unheard of amounts are continually being invested into the AI arms race.
Data centers are actually under construction. The first of them are under construction in Texas.
In 2028, as these massive projects come online, the power demand from AI will increase exponentially. By 2030, power demand will be many times higher. In this situation, U.S. big tech speaks with one voice. Low carbon emissions, consistent energy production in any environment. Nuclear power is the only solution. So, how does nuclear power generate electricity? In a nuclear plant, 1 centimeter uranium pellets are packed into tubes to make fuel rods. Placed in the reactor, they undergo fission and produce heat. The heat boils surrounding water into high-pressure steam, which turns a turbine to generate electricity. The key heat transfer medium in this is water. But recently, a new nuclear reactor that doesn't use water has emerged. The 4th generation advanced small modular reactors, SMRs.
냉각제가 물인 경우가 3세대고요. 4세대는 물 이외의 다른 냉각제를 쓰는 거. 예컨대 가스를 쓴다거나 그다음에 또 용융염 이런 것들을 쓸 수 있거든요.
2011년도에 그 일본의 후쿠시마 사고가 있었지만 그때는 이제 해결료 냉각이 잘 안 돼서 그 녹은 해결료가 녹은 사고였거든요. 근데 이제 4세대 원자로에서는 원자로가 그 냉각이 안 돼서 그 녹는 확률이 거의 제로라고 보시면 됩니다. 예, 그래서 우리가 항상 그 원자로를 얘기할 때는 어드밴스드 SMR이라고 그렇게 4세대를 표현을 하고 있습니다.
In AI-based high-tech industries, China has already grown to rival the United States.
China views power generation as a life or death issue for the economic development and for the living standards of Chinese people.
China was quick to recognize the importance of next-generation reactors for the AI era and moved fast to develop them. In 2023, it achieved the world's first commercial SMR operation.
The nuclear power station will not melt, even in extraordinary circumstances, mainly because it uses a combination of technologies to make sure that it will be safe in normal operation.
SMR power plants are built to endure even a magnitude 9.5 earthquake and remain secure, even if struck by an aircraft. With this unparalleled safety, they can stand right beside industrial complexes. Extra modules can easily be added to match needs, cutting construction time and allowing flexible response to demand. Because of these advantages, China is projected to have the most SMRs in the world by 2050, more than 3 times that of the United States.
그러니까 미국이 그만큼 역량이 안 되는 거예요, 원자로. 그러니까 미국은 지금 에너지 국가 안보라는 게 지금 원자력 산업 자체를 다 빼앗기게 되고, 그다음에 원자력이 이제 안보 측면, 밀리터리 쪽에 엄청나게 쓰이는데 그거를 유지하고 더 고도화시킬 인력들을 킵해야 되거든요.
Unlike China, the United States is growing its SMR industry by supporting private companies. Key SMR players from the US and South Korea attended this nuclear forum.
I do want to talk about some of the specific benefits of SMRs through the lens of what Westinghouse offers.
So for Hotech, we have the SMR 300.
X-Energy, which received investment from Amazon, also joined this forum.
What is the project? One of our biggest customers is sitting in this room, Amazon. We talk to Amazon every single day. Amazon in October 2024 announced an ambitious target to deploy 5 gigawatts of new nuclear technology with X-Energy.
Amazon chose X-Energy's reactor to power its data centers with next-generation nuclear power. Their reactor uses helium gas as the coolant, which is regarded as one of the safest gases.
엑스에너지 헬륨 같은 경우에는 헬륨은 그 케미칼 중에 반응을 안 하는 비활성 가스잖아요. 가장 그 주위 물질을 괴롭히지 않는 그런 냉매죠. 그리고 또 헬륨이 좋은 점은 가스임에도 불구하고 열 용량도 크고 열 전달도 잘 되고 이런 특징이 있습니다.
In this reactor, helium is heated up to 750 degrees Celsius. If an SMR is built beside a petrochemical plant, that hot helium can also serve as the plant's heat source. Using one heat source for multiple purposes like this improves efficiency.
헬륨 냉각 방식 같은 경우는 1944년 미국에서 처음으로 이제 개발이 되었고, 그 개발된 것들이 독일이나 영국이나 일본 이런 여러 국가에서 실제 실증로를 통해서 검증된 기술입니다.
Helium coolant reactors use spherical fuel to improve the efficiency of heat transfer between the fuel and the helium gas. Inside each sphere are tens of thousands of tiny uranium particles, each with a protective coating.
우리 이제 원자로를 보면은 원자로가 이렇게 있고 그 안에 해결료가 들어가 있고 원자로 있는데 바깥쪽에 이렇게 돔이 있죠. 이렇게 큰 돔. 혹시 여기서 뭐 방사능 물질이 나왔다거나 이랬을 때 이 돔이 그거를 다 가두는 거죠. 그 안에다가. 밖으로 못 새어나오게. 그렇게 되는데 얘는 해결료 조그만 거, 그 좁쌀만한 것마다 다 경납 용기를 다 씌운 꼴이에요. 그러니까 걔가 거기서 이제 핵 분열을 하고 방사능 물질을 배출하면은 그게 그 바깥쪽에 그 다공성, 구멍이 많은 그 카본에 그 가스가 다 박혀요. 그거를 또 다른 껍질이, SiC 껍질이 또 막고, 또 바깥쪽에 또 카본 막고, 또 SiC를 막고, 그래서 여러 층으로 트리소를 만든 거예요. 그렇게 돼서 하나하나가 다 경납 용기를 쥐고 있는 거예요.
During fission, uranium kernels heat to about 1,400 degrees Celsius. But TRISO X spheres maintain integrity above 1,800 degrees Celsius, meaning structurally fuel melting cannot occur.
And it's physically impossible to melt because it's encased in ceramic material that doesn't melt at any of the temperature scenarios that our reactor would see. And when you start with a reactor that cannot melt, you do not need all of the elaborate and expensive safety systems around that reactor that would operate in the case of a loss of coolant and a meltdown situation.
Conventional reactors must shut down to refuel, which adds operating losses. This new reactor is designed so that the fuel that has been depleted after multiple cycles is replaced automatically, enabling continuous operation without a shutdown. Based on this innovative technology, X-Energy and Bill Gates' TerraPower were selected for the U.S. DOE Advanced Reactor Demonstration Program, securing around $1.2 billion in support.
여러 가지의 아이디어를 내 가지고 여러 회사들이 경쟁적으로 개발을 하고 있지만 일단 상업화가 일단은 빨리 데몬스트레이션 할 수 있는 원자로가 무엇이냐 그 기준, 그다음에 어떤 것이 가장 안전성이 높고 또 상업화하는데도 걸림돌이 없겠느냐 해서 엑스에너지의 하이 템퍼처 가스 쿨드 리액터하고 그다음에 테라파워의 소디움 패스트 리액터가 선정이 된 겁니다.
In 2022, X-Energy began building a plant to produce next-generation nuclear fuel. To support this, the U.S. government agreed to supply next-generation high-assay uranium. Soon after, X-Energy secured strategic investment from DLE&C, and both companies expressed the possibility of engineering cooperation for the plant.
We are benefiting from significant support from the Department of Energy for our very first site, which is in partnership with Dow Chemical. It will be in Texas. It will be 4 of our reactors. DL is working with us on standardizing the plant design.
We both with X-Energy carry out engineering work, and our philosophy was to maximize the modularization in order to minimize the safety issues and quality problem.
DLE&C saw SMR's potential early on and actively sought promising partners to collaborate with.
80개를 전부 다 검토를 사실 했고 투자할 때 사실 2023년만 하더라도 이런 SMR 기술들이 막 여기저기에 난립이 되어 있는데 이 중에 누가 성공할 거냐가 다 불확실했어요. 실제로 당시에 유망하다고 여겨져 왔던 회사는 도산을 하게 됐고, 엑스에너지는 당시에 재무적인 어려움이 있어서 크지 못할 거다라는 내부 전망도 사실 있었고, 이거는 저희 회사의 단일 조직만 검토한 게 아니라 수많은 기능이 이 투자 그리고 앞으로의 예상되는 협력 구도 그리고 미래 전략까지도 다 함께 머리를 맞대고 고민을 했고 어려운 의사결정을 한 것이라고 생각을 하고 있습니다.
No matter how much due diligence you do, no matter how much research you do, there's always going to be a little bit of risk that you take, and DL was willing to do that for us. When we were still sort of starting out on our journey to develop our reactor several years ago. And we will forever be thankful for that kind of partnership, for somebody who took a leap of faith and worked with us.
At the time, Doosan Enerbility invested in X-Energy alongside DLE&C. Doosan Enerbility, a global leader in nuclear reactor manufacturing, recognized worldwide for its excellence in both reactor and turbine technologies. The 3 companies formed a strategic partnership and have been working to combine their strengths.
저희는 이제 EPC 역량이 가지고 있지만은 두산 같은 경우에는 EPC 쪽보다는 이제 원자료를 만들고 이런 역량이 뛰어나니까 이렇게 저희가 협력할 게 있는지 같이 이렇게 연구하고 찾아보겠습니다.
Power plant construction is a highly technical project that requires integrating many critical systems. DLE&C has successfully built numerous plants in Korea and overseas.
플랜트 같은 경우는 그 부정결합이 발생하지 않도록 정확하게 굉장히 차원이 다른 어떤 그런 이제 정확도를 요구하는 어떤 그런 프로세스가 되겠습니다.
When design meets the field, there are often unexpected variables.
실질적으로 이제 설계를 했다라고 하더라도 완벽한 설계는 있을 수가 없습니다. 현물을 다루는 입장에서는 정확히 맞아야 되거든요. 그게 이제 설계적인 미스매치가 발생을 했을 때는 어떤 그 수정에 대한 어떤 그런 방법들을 저희들이 이제 프로포즈를 해서 설계에 맞게끔 이렇게 현장에서 수정을 하고 치밀하게 매뉴얼에 이제 근거를 해서 설치 계획을 짜야 되는 어떤 그런 부분들이 있습니다.
DL-ENC has extensive experience installing major systems at domestic nuclear plants. And Korean construction companies recently proved their capability in the global market with the successful completion of all 4 UAE Barakah units.
Korea is one of the few entities and industries in the world that has successfully built nuclear reactors in the 21st century. We need that. If we want to be successful, we need to harness that expertise and work with the best, as I mentioned before, and the best exists in Korean industry. So that is Doosan Enerbility, that is DL-ENC.
저희는 사실 투자에만 그치진 않았고 어떻게 하면은 이 기술이 이 시장에서 주도를 할 수 있을까? 오랜 기간에 걸친 엔지니어링 경험이라던가 안전관리의 영역이라던가 경제성을 개선하는 관점에서의 접근이라던가 뭐 모듈화 설계라던가 이런 부분들을 지원을 했고요.
In modular construction, major plant structures are manufactured off-site, then transported to the site and assembled there. The design accounts for various factors such as transport feasibility, road conditions, and vessel load limits.
네, 그런 공정들을 저희가 한 10년 전부터 모듈라를 적용하면서 수행해왔던 역량들이 축적되어 있기 때문에 이 시스템을 딱 봤을 때 이것도 모듈라가 가능하다라는 그런 판단이 저희는 섰었습니다. NILB, 그러니까 원자로에서 터빈 빌딩으로 넘어가는 보조 빌딩. 실질적으로 모듈을 적용해서 건설한 사례가 한 번도 없습니다. 근데 작년에 미국 가서 이 디자인을 처음으로 발전소에다가 모듈 컨셉을 적용했고요. 이 컨셉을 그 사업주한테, 엑스에너지한테 보여줌으로써 이런 식으로도 모듈화가 가능하다라는 것들을 실질적으로 현실적으로 자각을 하게 했고, 그거를 토대로 해서 이뿐만 아니라 또 다른 일반 터빈이 있는 발전소 전체 개통에 대해서도 모듈 컨셉을 연구해 달라는 걸 요청을 받아서 저희가 지금 현재 스터디를 진행하고 있습니다.
DL-ENC is modularizing various basic plant designs based on X-Energy's reactor. This is a key strategy for cost and schedule reduction.
If you look at the nuclear industry and all of the operating reactors in the United States, each one of them is its own bespoke, special design. There was no standardization. There was no fleet scale order book and manufacturing that we were ever able to achieve.
Because of the lack of standardization in the U.S., Vogtle Units 3 and 4 project pushed construction costs to over $30 billion, more than twice the original estimate. This led Westinghouse to bankruptcy and is seen as a key case which led to the broader downturn of the U.S. nuclear sector.
So in terms of what DL has been able to already help us do is addressing that challenge of standardization. Different customers will want different things. So there is going to be a degree of specialization across different sites, but what we need is to have like a model, okay? A model on the shelf of like, okay, this customer wants X, Y, and Z. Okay, that suits model B. So we take that design off the shelf and look, we have a standard configuration that suits the customer's needs. And that's that. And that will be something that we have never successfully done in the United States. So already, DL has helped us wrap our minds around the challenge.
Standardization enables mass production and cost efficiency, making the global rollout of SMRs possible. X-Energy, together with DL-ENC, is now expanding into global markets.
동남아에서 이제 에너지 관련 부처, 정부 부처들이 모여가지고 SMR 도입할 수 있는지, 그리고 도입한다면 어떤 기술들이 있는지 그런 것들을 이제 서로 소개하고 네트워킹하는 그런 자리.
동남아 국가가 이제 특성도 있잖아요. 필리핀은 섬으로 많이 되어 있고 인도네시아는 지진에 약하고 각 국가마다의 특성들이 있는데 SMR은 그런 안정성을 이 대형 원전보다 100배, 1000배 높인 안정성을 가지고 있기 때문에 지진에도 강하고 섬에서도 좁은 풋프린트도 이 SMR 발전을 설치할 수 있는 그런 장점이 있고요.
So tell me, what can your company do such that we will hit the 2030 goal?
X-Energy and DLE&C now move as one team with one strategy. Centered on a standardized SMR power plant model, the plan is to optimize it for the conditions of each Southeast Asian country.
You can configure the site, and our DL partners help us do some of that design.
We've been working in Indonesia. These are the, I mean, it is there, but these are the list of the projects. We know all the construction conditions, supply chain. 동남아형 사업 모델을 접목을 해서 각 국가별로 저희가 접근을 하려고 하고 있고요. 필리핀, 인도네시아, 베트남 이 세 개 국가를 중심으로 앞으로 그 핵 확산 금지 조약이라든가 섹션 1, 2, 3가 미국 정부하고 합의가 되는 이런 국가들 중심으로 확장을 할 예정입니다.
Seeking to regain nuclear leadership with its own advanced reactors, the U.S. government is also showing strong interest in X-Energy and DLE&C's Southeast Asia strategy. Nuclear plants are nationwide projects with astronomical costs, so international financial institutions are also looking out for potential investment and participation.
How can we help to accelerate the big things? You know, you say 2030, 2031, we're in 2026 very soon.
Yeah.
So this is 4 or 5 years away, it's not that far.
We need to be producing one steam generator, one main power system, one reactor pressure vessel per month, starting in a couple years. That pace is unprecedented. So this is not just an amorphous, oh, we need to work together kind of partnership. This is, I need concrete investments. I need concrete structures to be built. I need to deliver components and I need them on a set time frame. The only way to do that is together. So that's the vision I see for us and for ROK nuclear industry.
Because of the geographical and environmental constraints, some countries were once cautious about nuclear energy. That has changed. With strong government backing, they're using SMRs to redraw their energy future.
Quite frankly, given the number of islands and installed bases within the Philippines, as well as the possibility of being able to deploy it in close proximity with heavy load centers, it's something that honestly matches what we're looking for. DL built quite a number of power plants, bridges, and infrastructure projects. What we want is to translate these from power points to power plants. And that's where we hope DL can support X-Energy in realizing that dream.
Our government is really aggressive in this. Nuclear energy is a landmark investment that would somehow help us prepare for the future. We're quite confident that we will go a long way with DLE&C as our partner. We will make this dream come true and we will get this done. We'll execute this.
Now, DLE&C looks beyond SMRs to the new future that SMRs will bring.
저희가 SMR 분야에 경쟁력이 있다고 해서 SMR 발전소를 설계하고 건설하는 분야에만 집중을 하진 않을 거고요. 저희는 SMR과 AI 데이터 센터를 연계한 하이브리드 모델, 그리고 SMR과 석유화학단지, 저희는 그래서 한 분야에만 머물러 있지 않고 앞으로 발전하는 사업 분야를 접목을 해서 이런 밸류 체인을 연결을 하는 것을 최종 목표로 생각을 하고 있습니다.
The whole world is running in the SMR mega race. And now, DLE&C are picking up the pace.